Hello, welcome to the second osmosis screencast. We're talking about this classic experiment where we have a thistle funnel inverted with a semi-permeable membrane at the bottom of it, and we have a liquid in here and a liquid in here. Now if both liquids were water molecules would be able to move down and across or up and in, and they would move theoretically at the same rate in one direction as in the other direction, except that the force of gravity pulling down on this liquid would actually push more water out than in, and the level of this liquid would slowly drop until it was level with the liquid in the beaker. However, we don't in this example have water in the beaker and the thistle funnel. We have a sugar solution in here. So the beaker contains 100% water and the thistle funnel contains 60% water and 40% sugar. So if we consider this membrane here, we've got a magnified image here, and even more magnified, we've got individual particles here. So we play the same game, random movement of particles. The water particles in black can move across the membrane, but the sugar particles are too big and cannot. So let's play our game. Water particles in exchange, but sugar particles can't go through. Water particle up, water particle down, water particle up, sugar particle can't go through. So if we play this game in the way I've stated before, what we find is that although the water molecules pass across the membrane perfectly well, the sugar particles don't, and therefore we get a more even distribution of water particles, but because of the sugar particles we end up with more particles above the membrane than below. So water has diffused so that the water concentration on both sides is more equal. We've now, say, got 80% water above and 100% water below, so it's more equal. However, that means we've actually got a greater volume above the membrane, so this liquid volume will increase. In fact, the stronger the sugar solution in here, the higher the level of liquid. So it's a measure of the osmotic potential of a solution. Concentrated salt or sugar solutions will cause more water to rise, even though gravity is trying to work in the other direction. But it's incredibly important for you to understand that water molecules are constantly moving in both directions across that membrane, in both directions, up into the solution and out of the solution. Water molecules will move in both directions. However, there is a net movement of water in this direction. Water is more concentrated down here than in here, so diffusion will try to even out that inequality. So more water will move in than moves out, and therefore this volume will increase. I hope that's clear. Watch 1 and 2 again if you're not clear on it, and if you've got any questions, just drop us a question on the internet and we'll see if we can answer it for you.